Hi, welcome to another 4AC learning video. In this video, we want to look at example 3.9a, which is found in your lecture notes toward the end of topic 3. Example 3.9a reads as follows. It is given that Vs, the voltage source, is 100 at an angle of 45 degrees volt, and a current source Is is 15 at an angle of 30 degrees ampere, and there are two impedances in the circuit. Impedance Z1 is 30 plus J60 ohms, and impedance Z2 is 30 at an angle of minus 90 degrees ohm. Now if you could recall, minus 90 means this is a pure capacitor, and Z1 is 30 plus 60, so it's a combination of a resistor and an inductor. Now what are we required to find out? Number one, we want to find the currents flowing through Z1 and Z2 in their polar form. The current flowing through Z1, which is labeled here as I1, and the current flowing through Z2, which is labeled as I2. And then what do we want to do? We want to find the power delivered from Vs. Remember, power can only be delivered in the resistive element. And what is the power delivered by Is to this system? Okay, let's see how we can go about answering this type of question. Alright, to answer this question, we need to look at Kirchoff Voltage Law. Now basically what the law says that in any closed circuit, the sum of the source voltage Vs must be the same as the voltages across the various components. So in this case it's V1 and V2. So we have V1 and V2. Now about V1, we can compute it with I1 Z1 plus I2 Z2, and that's our first equation which we want to use. The other one is using Kirchhoff current law. Kirchhoff current law says the total current coming into a node, in this case node B, is equals to the sum of the current coming in and going out. So in this example, I2, which is leaving the node, must be equals to I1, which is coming into the node, plus Is, which is the source of the current. Now with these two, I have equation 1 and equation 2. So if I were to substitute equation 2 into 1, I will have an equation which is only having I1, which is what I want to calculate first. So let's do that. That means substitute equation 2 into equation 1. I will have Vs equals to I1 Z1 plus, instead of I2, I replace it with I1 plus Is Z2. Rearranging it, I will have I1 Z1 I1 times I2, so I have I1 times Z2 plus Is times Z2. Now since I1 is common to these two, I can group them together, and I call this Z1 and Z2, which is actually the total impedance. Now with the new equation, I have everything which is given to me except I1. So what I can do is I will then substitute the numbers into it, right? So rewriting this, I will have I1 Z1 plus Z2 equals to Vs minus IS Z2. Put in all the numbers that I have. Z1 is given as 30 plus J60. So I have 30 plus J60 plus Z2, which is given as 30 angle minus 90 degrees. Is equals to Vs, which is given as 100 volt angle 45 degrees. That is Vs. Minus Is is given as 15 angle 30 degrees. Multiplied by Z2. Z2 is given as 30 angle minus 90 degrees. Okay, so now all I need to do is all these phasor or complex numbers. So for this multiplication, I can go ahead and do it. For this, I have to convert to the rectangular form and add on to this. Now you recognize that this is minus 90. So if I were to convert this, 30 angle minus 90 degrees is just minus J30. Right? So if I were to put it here, basically what I get is I1 bracket 30 plus J60 minus J30. So plus J30. And that equals to 100 angle 45 degrees minus 15 times 30 is 450 at an angle of 30 and plus minus 90, so become minus 60 degrees. So this formula now, because of the minus sign, I convert this to rectangular, convert this to rectangular as well. I convert this to polar because I want to eventually divide. So what I get here is I1 30 and J30. 30 and J30 will give me 42.43. 42.43 at an angle of 45 degrees. That's equals to 100 angle 45 is actually 70.71 plus J 70.71 minus 450 angle minus 60 is actually 225 minus J 389.71. Okay, now that it is in rectangular form, I can just the real minus, that means 70.71 minus 225, J 70.71 minus become plus, so 70 plus 389. So what do I get? Let me open up this thing. I will have I1 equals to, now I'm ready to bring the other one over. Okay, so I will have, instead of 42.43 here, I write here 42.43 at an angle of 45 degrees. And then from the top, I will end up with 70.71 minus, so that will give me minus 154.29 plus J 460.42. So to do the division, I have to convert the top numbers into a polar form, which is 485.58. So 485.58 at the angle of 108.5 degrees divided by 4243 angle 45 degrees. So that gives me I1 as 11.44 angle 63.5 degree ampere. Now once I know I1, I can then use equation 2, which is I2 is equals to I1 plus IS. I1 plus IS. So that will be 11.44 at an angle of 63.5 degrees plus IS, which is 15 at an angle of 30 degrees. Now, since this is a plus, I have to convert to rectangular format before I can do some mathematics. So it's 510 plus J 10.24 plus 12.99 plus J 7.5. So the real part of the numbers, I can add them up. That gives me 18.09 plus J 17.74. Convert that to polar and I will get 25.33 at an angle of 44.4 degrees in ampere. So here you are, I get I1 and I get I2. Okay, so that is part 1. Now part 2 wants me to calculate what is the power contributed by Vs. So to calculate power, I need to fall back on the formula. Power by Vs is actually the voltage Vs times the current that is coming out of Vs, which is I1. Cosine of the angle of Vs minus the angle of I1, the current that is coming. So that will give me Vs is 100 volt, I1 is 11.44 ampere, cosine of the angle Vs is 45 degrees, which is given, minus 63.5 degrees, which is the angle of the I1. So that gives me 1084.91. Okay, and finally we want to know the power that is supplied by I source. Now I source is actually the current. So if we look at it, the source that is contributing is actually V2. So it's actually, if I write the formula out, it should be V2 and I2. Cosine of the angle of V2 minus the angle of this should be the current contributed by IS and the angle of IS. Okay, because IS, if you look at this, IS has the same voltage as V2, right? Because I is here and V2 is here. So we need to calculate V2 first. Now V2 can be calculated easily by I2 times Z2. That's equals to 25.33 at the angle of 44.4 multiplied by Z2, and Z2 is given by 30 angle of minus 90. 30 angle of minus 90 degrees. So that gives me V2 of 759.9 angle of minus 45.6 degrees volt. So V2 magnitude I can use, or the RMS value is 759.9. So I can substitute into here 759.9 multiplied by the current, which is 15, cosine of the voltage angle is minus 45.6 degrees minus 30 degrees. So that gives me a power of 2834.7 watts as the power supplied by IS, whereas the power supplied to VS is 1084.9 watts. Okay, so that's my answer, or my working for example 3.9a as found in your lecture notes. Thank you for watching. Hope you learned something from this video. Bye bye.